Albert Einstein. There's a lot more to this iconic thinker than just the craziest hairdo in physics. For instance, how did Einstein become a celebrity pinup? What does E = mc squared actually mean? And what happened to his brain? Luckily, you don't have to be a genius to figure out the things you need to know about Einstein. So, did Einstein spend 7 years as a cobbler? Germany, 1879. Mr. and Mrs. Einstein gaze upon their newborn baby, concerned about his large, misshapen head. They needn't have worried. This head contained one of the greatest brains in history. But as a young boy, little Albert was slow to talk. The maid even called him the dopey one. So his parents took him to see a doctor. It turned out he just preferred speaking in complete sentences.
Einstein, as a young boy, started to query the world he was living in. He was fascinated by natural phenomenon.
Einstein said himself that there were 2 wonders that affected his early life. One of these was when he was given a compass at the age of 5, and he was mesmerised by the needle that would move around and these mysterious forces that were causing it to move. The other thing that he loved was his geometry book, which he was given when he was 12. He devoured this book. And so, yeah, clearly he liked mysterious things and mathematics.
His understanding of, say, science was perhaps different to most other children.
Einstein certainly wasn't a dummy in the classroom, but he didn't like being told what to do, which often got him in trouble with his teachers. In fact, he called the schools barracks and the teachers lieutenants. Without a single qualification to his name, Private Einstein became a teenage high school dropout. He also flunked the entrance exam to Zurich Polytech, but tried again at 17 and aced it, only to become a bit of a rebel, skipping classes and arguing with the teachers.
His attitude towards the teachers perhaps was not one of great respect, because he felt that he probably wasn't being given the whole truth. He was being told half-truths, perhaps.
He felt that the education system stifled creativity and originality, and so he was never happy at school.
He would be not paying attention. He would be questioning some of the things that the teachers would be telling him, and they would be frustrated with this boy. I guess they would get very frustrated with him, actually, in terms of his attitude to them, because they were not getting the respect that they thought they should be getting from someone of his age.
Didn't like rules, and that doesn't go down well in schools. It still doesn't, or at least it didn't when I was at school.
One professor was so miffed by Einstein's disobedience that he did his best to sabotage his academic career, which is why at the age of 22, Einstein was unemployed with no prospects and a pregnant girlfriend. Luckily, he landed a junior post at the Swiss Patent Office in Bern, doing the sort of work he referred to as his cobbler's trade. So no, Einstein didn't spend 7 years mending stilettos, but he did do plenty of what he loved best, thinking.
He has referred to that time as being a very positive thing, and certainly in 1905, when he wrote these great papers, several great papers, he was doing that work in the patent office whilst carrying out his job as a patent clerk. So it evidently did no harm to his ability to do good physics, and I think he referred to it positively in the sense that he didn't have the distractions that you might have if you were in academia.
What was Einstein's big idea? Imagine you're chasing after a bus. It's doing 30 miles an hour, but you only manage 29. The bus is faster than you by 1 mile an hour. Speed up just a bit, and you'll catch it. But if the bus were a beam of light, then no matter how much you speed up, it's always faster than you by the same amount. The speed of light. This doesn't seem to make much sense. But by the start of the 20th century, experiments had shown that it was true. What on earth was going on?
At the end of the 19th century, this problem arose. Light in a vacuum has only one speed. No matter whether you're moving towards it or moving away from it, you will always perceive light to be moving at the same speed.
It's always 300,000 kilometres per second or thereabouts. And this is a little bit odd. It's not what we experience in everyday life.
A duck swimming over the surface of a pond generates water waves. And those waves, if the duck's swimming along, they kind of bunch up in front of the duck and kind of spread out behind. Everybody's familiar with that. What the duck's doing is essentially catching up with the waves it's generating in the water. So you would expect light in much the same way that if we chase after light, we generate light, that we should be able to see this effect of the fact that the waves change the speed depending on how we're moving.
The experiments at the end of the 19th century showed that was not true, actually. And light, indeed, was constant.
That flies in the face of common sense. I mean, that sounds like the statement of a lunatic, almost. I mean, it really is a ridiculous thing to suggest.
This perplexed most of the early 20th century scientists, and they just could not come to reconcile the fact that there is a problem with the constancy of the speed of light.
It took one of Einstein's famous thought experiments to sort it out. Let's say Mr. and Mrs. Einstein each have identical relativity clocks. These super-accurate timepieces work by bouncing a photon of light between two mirrors a few feet apart. Now, if Albert hurtles past at near the speed of light, Mrs. Einstein would say that his photon has to travel much further between ticks than hers. So, to keep the clocks ticking together, his photon would have to speed up. Except, we already know that light doesn't do that. Einstein reasoned that time itself, not light, changes speed.
He simply took this idea seriously, that the speed of light is constant. And that means that the very notion of what space is and what time is, has to change.
He realised that the speed of light was constant, so something else had to change. If it wasn't distance, the only thing left was time.
So he reformulated a theory of what space and time is, and the bottom line is that they're both subjective things.
So this meant that time itself was no longer absolute, it had to be relative. And this is the big breakthrough that Einstein made.
Now, this is a very counterintuitive thing to say, but it turned out to be right.
Of course, it's reasonable to assume that this happens for all velocities, and it does, but it really is only observable when you're moving close to the speed of light.
Relative to Mrs. Einstein, Albert's clock ticks slower than hers. The faster he goes, the slower it ticks, until at the speed of light, it would stop altogether. Bingo! Einstein had shown how nothing travels faster than light, not even celebrity gossip.
There's no doubt that Einstein's theory is disorientating. And I think the main difficulty that people have in getting to grips with it is that it seems so unbelievable that when you try and digest the ideas, you end up thinking, because it's so weird, I must have misunderstood something. It can't be this strange.
I think it's difficult to grasp because it's counterintuitive. It's really not normal to think about how you can catch up with a light beam or what would happen if you did. It's not what we experience in everyday life, and I think that makes it difficult to comprehend.
And in fact, the ideas and the mathematics that underpin them are very simple. It's not very complicated. The difficulty is in the way they challenge our view of the world, and it's a very disorientating experience. It's a little bit like, climbing up to the top of a tall ladder or something, and don't look down, right? So the climbing up's easy, just take the steps, do it logically, step by step, and you can follow Einstein. You can draw the same conclusions that he draws, but don't look down. It's very, very confusing.
What does E = mc squared actually mean? The world's most famous equation simply states that E, or energy, equals mass, m, times c, the speed of light, times itself. And because c² is a really big number, even a really small piece of matter like a paperclip equals a lot of energy. 18 kilotons of TNT's worth, to be exact. or one atom bomb.
E equals mc squared is an equation we're very familiar with. And I think we're familiar with it because it's so short. And yet, it covers a wealth of information.
And this is a profound equation that took him a number of years to really get to grips with. But basically, he had shown in that equation that the energy and the mass are equivalent.
Imagine that you're in a spacecraft and you're accelerating up towards the speed of light. Now, the rockets are firing really, really hard as they've been doing all the time. But as you approach the speed of light, you find that you're accelerating slower, so you're not reaching the speed of light, but your rockets are still firing. So you've still got all that energy that has to go somewhere. If you're not getting any closer to the speed of light, you're actually becoming harder to push. So that means that you're getting heavier. So your mass is increasing. So that energy from your rockets is actually going into increasing your mass. So Einstein realized that mass itself is a form of energy, and that's the essence of E equals mc squared.
But it tells us more than that. It tells us that a small amount of matter can be converted into a huge amount of energy.
It doesn't even matter what that matter is. Marmalade, moon rock, or a monkey's earwax. It's all atoms, which in theory can be converted to energy. The problem is, releasing that energy requires an awful lot of, well, energy. One way to do it is nuclear fission. Take one large atomic nucleus like uranium, split it in two, and a little bit gets converted to energy, along with some nasty radioactive byproducts. Then there's fusion. Take two hydrogen nuclei and stick them together to produce one helium nucleus, and some energy. But first, you'll need about 100 million degrees Celsius, which is why stars, like the sun, can do it. If we could crack it here on Earth, controlled fusion would give us unlimited clean energy.
Einstein's equation raises this possibility, the possibility to use nuclear fusion to generate energy.
Today, we are living in an energy-starved world. And so E equals mc squared gives us hope for the future. It means that if we crack fusion, we can actually generate a huge amount of energy with a small amount of matter.
A power station, a fusion power station, in one day would use about 1 kilogram of fuel. That's like a big bag of sugar. Whereas a coal-fired power station every day uses hundreds of truckloads of coal. So it gives you an idea of the amount of energy that we can get from fusion.
Sounds too good to be true? Well, so far it is. The only energy-efficient fusion we have achieved is the hydrogen bomb. And that's most definitely not controlled.
The possibility to exploit nuclear fusion on Earth in a controlled way, not through making a bomb, to generate large amounts of energy is a very realistic one.
We are getting very close. It's been a long process since about the 1960s. But over the last few decades, a lot of progress has been made in general plasma physics, and also how you control a gas that's about 100 million degrees, which is the temperature that we need for fusion. Now, this is quite a challenge, but actually we've done fusion on jet, which is the biggest fusion machine in the world currently. We've made real fusion reactions, but we haven't yet got past break-even, which is obviously quite important if you want to make a power station. But hopefully in the next few years, we'll be getting towards break-even.
It works the other way around. We can convert energy into mass. That's what we do all the time at the Large Hadron Collider at CERN. Two protons collide. The protons carry sufficient energy that when they collide, a whole pile of particles comes out. So the protons disappear. These particles weren't inside the protons in any way. We're literally exchanging the energy of the protons for mass.
Lots of crazy, unknown, mysterious particles come to life, even for fractions of seconds, and they study them. Things like bosons and pions and kaons. These all come from energy.
So if you like, E equals mc squared is the tip of an iceberg.
How did a man falling off a roof change our universe? Einstein knew that his first theory of relativity was missing something: gravity. So he relabeled it special and got cracking on a brand new version, which he called general relativity. The story goes that Einstein was sitting in his office when he saw a man fixing a roof. He imagined the poor chap falling off and had what he called the happiest thought of his life. As the man starts to fall, he is effectively in zero gravity. Put him inside a large windowless box that's also in free fall, and he has no way of knowing that he's moving. That is, until he hits the ground. Einstein realised that gravity is actually an illusion, although its effects were still as real as ever.
If you think about how you feel on a roller coaster, for example, when you're going up and down, that's just like having gravity turned on and off.
So if you just jump off the top of a building, then as you're falling down, it's like somebody's just turned gravity off.
And Einstein had come up with profound new understanding of how the universe behaved.
It took him 10 years to work out the details. But in 1916, he produced a brand new picture of time, space, and gravity. And in this new universe, gravity slows time.
He took space, 3D space, and merged it with time and came up with the concept of space-time.
It's a difficult concept to grasp.
What is space-time? I mean, it's nothing, is it?
Four-dimensional space-time is something that is impossible to visualise because we live in a three-dimensional world.
There's up, down, left, right, forward, back, and then there's another direction, which I can't point in it, unfortunately, because I can only ever point in space. But this other direction, if I could point in it, it's the time direction.
We generally think of space-time as a rubber sheet. Now, if you're considering gravity, gravity is a depression in the rubber sheet. So if I have a planet and I put it in my space-time, it deforms space-time, and that is my gravitational well. So we're not just thinking of it as a force, we're thinking of it as a perturbance in space-time.
We say that the force of gravity acts to make their paths curve around the bigger object. But if gravity doesn't exist, then there has to be something else that allows objects to move in a straight line, but for their paths to appear curved. And there is. A curved surface will do the same job. So if you think about flying from London to New York and you want to go by the shortest, straightest route, you can go in a direct straight line. But if you look at that line from space, you'll see that it's actually curved because you'll be going around the surface of the Earth.
That's the big clue. If space and time curve, then objects that are everywhere in free fall end up following interesting curved trajectories like planets orbit, things like that. So they're orbiting, in effect, they're in free fall, but free falling in a curved space.
So Einstein realised that a curvature is essentially the same as gravity. So we get this curved four-dimensional space-time, and this is actually equivalent to gravity.
Gravity is actually creating its own structure within the universe.
Because Earth's gravity gets weaker the further away from its centre you are, your head ages faster than your feet by 1/100th of a billionth of a second every day. By your 80th birthday, your cranium has gained a good 300 nanoseconds on your tootsies, or about 1/1,000,000th of the time it takes to blink.
General relativity was truly thinking outside the box. It was using thought experiments, a method he used to envisage things that no one had conceived before.
General relativity, I doubt if anyone would have come up with that for a long time. The way he actually thought about the problem, the way he put it together, was unique, and it was unique to him.
It wouldn't be unreasonable to assume that if Einstein hadn't been there, we may still be waiting for general relativity.
How did Einstein become a celebrity pin-up? It's Einstein's 72nd birthday party. A photographer asks him to smile for the camera. Instead, the ageing professor engages in a cheeky spot of glossal protrusion. This snapshot became so famous that in 2009, an autographed copy sold at auction for nearly $75,000. Ironically, Einstein's meteoric rise to fame began with the stars. In 1919, Sir Arthur Eddington photographed them during a solar eclipse and confirmed that gravity bends light. So Einstein was right, and just about everything we thought we knew about space, time, and the universe was wrong.
The first indication that Einstein's theory was right, well, it depends who you ask. If you ask Einstein, then I think he was utterly convinced. In fact, he was famously asked what he would have done if Eddington's experiments had not confirmed his general theory of relativity, and he said that in which case I would have pitied the poor Lord. It was too beautiful to be wrong.
Almost overnight, Einstein's mug became global front-page news.
When it hit the newspapers, Einstein became an overnight celebrity throughout the whole world, not just among scientists, but among just normal people.
This was something completely new and something that people weren't expecting. So when this theory was actually shown experimentally to be correct, it caused a lot of excitement.
General relativity caused a real international stir when it hit the headlines, which is quite unusual for a scientific theory. But I think general relativity taps into something that we all feel. It's giving us a better understanding of the universe that we live in.
The Newtonian view of the world was utterly shattered.
And that's when Einstein became a celebrity.
At first, he didn't exactly welcome the attention. He told a friend, "I dream I'm burning in hell, and the postman is the devil eternally roaring at me." But he soon got used to the glare of the spotlight. By the time the Einsteins relocated to America in 1933, they were hobnobbing with the rich and famous. Albert's wild hair and drooping moustache were a cartoonist's dream. As instantly recognisable as Mickey Mouse, and almost as easy to draw. Which is why, ever since, just about every absent-minded professor and mad scientist looks a bit like you-know-who.
I think, really, his work, starting with the special theory of relativity, had completely upturned, what seemed like a metaphysical issue. What's the structure of space and time? That it seems like that might not have anything to do with science, but Einstein had brought that squarely into the domain of science. The idea that physicists were starting to map out and address questions like that, I think that captured the imagination of a public around the world.
Ever since man could, we've looked up at the night sky and wondered what's out there. And Einstein gave us a better window into what's out there.
What was it like to live with a genius? During his girlfriend Mileva's pregnancy, Einstein wrote her a soppy letter. "I am filled with such happiness and joy," he wrote, "that I must share it with you." Ah, sweet. Except the previous line of her Valentine read, "I have just read a wonderful paper on the generation of cathode rays."
Einstein and Mileva had their first child actually before they were married. They had a daughter named Liesel.
This probably didn't make much of a mark on him because he remained back in Switzerland. So he wrote a couple of letters and he talked about the baby perhaps very briefly in the letters, and that was it.
Nobody actually knows what happened to her. There's no record of it. Maybe she died of scarlet fever, maybe she was put up for adoption. We don't really know.
Albert and Mileva did tie the knot and had 2 more children, but you'd hardly call them love's young dream. A few years into their nuptial arrangement, they shared a passion for physics, but not much else. He once said, "Marriage is the unsuccessful attempt to make something lasting out of an incident," and called Mileva an employee he couldn't sack. He even drew up a kind of legal contract, ordering her to do his cooking and laundry, prohibiting any sort of intimacy, and demanding that she stop talking to him if he requested it. Sounds more like the Hollywood prenup.
Marriage probably didn't get off to a good start.
The work that Einstein was doing required intense concentration. He spent a lot of time lost in thought, which is kind of incompatible with having a young baby around, which is very distracting.
I think Einstein was very, very good at kind of blocking out distraction and was very single-minded in his science. And that combination, I'm sure, would have led to quite a strain on his personal life.
He was having to earn money, he was having to do his physics in the evening, and he was having to be a father as well as a husband.
Hardly surprisingly, it ended in divorce. Partly because Einstein had at least one affair with his first cousin Elsa, who then became his second wife. But despite many rumours to the contrary, he didn't have an affair with screen goddess Marilyn Monroe. The two never even met.
He was a bit of a flirt as well. He actually probably liked the girls. In fact, one of the reasons that he said he liked going to ETH was it was the only system in Europe at that level of education that accepted women. So he probably did like looking at lots of pretty girls.
Does God play dice? Einstein spent his last 30 years attempting to pull off his greatest trick yet. A unified field theory to explain just about everything in the universe. His own relativity theory described a sort of clockwork universe. Measure it accurately enough, and you could work out the past, and even predict the future. Relativity was great at big stuff, like universes, but rubbish at little things, like atoms. Quantum theory did this brilliantly, but said some really crazy things. Objects could be in many places at once. A cat in a box could be both alive and dead until somebody takes a peek. Worst of all, it said the fabric of reality is essentially fuzzy. Heisenberg's uncertainty principle said that we can never be 100% sure of absolutely everything, including the past and the future.
Quantum mechanics is definitely weird and very counterintuitive.
The most twisted and surreal imagination would never have come up with quantum physics if we weren't battered into it by the weight of the experimental evidence.
One of the things that's very bizarre about the quantum picture is that you can appear to have particles in different places at the same time.
Electrons can be in many different places at once.
We've got a particle travelling from A to B. In the quantum world, it can take many different paths at the same time.
So the object itself may or may not be there. And it's like actually having the moon behind you, but it might not be there. And it's only there when you turn around and look at it.
Einstein hated this idea, rejecting it by saying, God does not play dice with the universe. Niels Bohr, the champion of this disturbing new science, replied, "Stop telling God what to do."
Einstein was upset by the idea that the universe was founded on random chance.
What he didn't like about the quantum world was the fuzziness of it. It appeared to be very, very vague and fuzzy, and you could almost come up with any answer that you wanted.
He didn't like the fact that there's this apparently inherent randomness in things that limits our ability to calculate.
He always thought that there was going to be a better model round the corner.
It was more than 50 years before quantum mechanics could be tested by experiment, and Einstein was finally proved wrong. Yes, it's official. The world is essentially uncertain. God, it seems, does play dice after all.
Einstein didn't like quantum theory at all, and I think it's mainly because of the randomness of it. The outcomes seem to be very fluffy.
And the rest of his life, he was devoted to trying to develop a unified model that would actually show the unification between his general theory of relativity and this, what we call the quantum world. And he did not like the uncertainty.
And this is something that no one's managed to come up with yet. It's a huge task trying to align all the different parts of physics.
It's surprising to find that Einstein would try and fight the introduction of quantum mechanics for all these years, but you can't refute the fact that quantum mechanics is something that we use every day of our lives.
The world, as we are entitled to experience it, is random, so it seems, or has this random element within it.
What was Einstein's biggest blunder? Some might argue that Einstein's work gave us the atom bomb, which is a pretty big faux pas in anyone's book. But it seems his worst mistake was one of even greater gravity. Einstein used his equations to build a model of the universe, only to find that it should be expanding or contracting, but not remaining static, as everyone at the time knew it was.
What he was doing is he's trying to actually understand the universe from the point of view of gravity. And so he was using his most elegant theory of general relativity. And so what he found was that, there's a problem here. A couple of solutions. One is actually expanding, one is actually contracting. But we know it's static, so the static universe was the one that everybody thought was the correct one. So he thought, well, I can't go against what people thought, which was totally unlike Einstein. He would probably have said previous to this, well, everybody's got it wrong. The universe isn't static. But because our vision or understanding of the universe was so limited in terms of it just being the Milky Way, he had to go along with everybody else.
For once, Einstein wasn't thinking weird and far out. He was maintaining conventional wisdom that the universe was static, as we all expected.
Well, I think he thought the universe was static because there wasn't anything really to convince him otherwise.
And so his solutions to that problem didn't show that it was a static universe. And the universe was expanding and in his model, or it was contracting. So the idea was he's made a mistake somewhere.
Einstein bodged up a last-minute fix, adding a number he called the cosmological constant into his equations, a kind of negative gravity to counterbalance the effects of regular gravity. Even at the time, he knew this was very dodgy science.
He had to introduce a fudge factor, and the fudge factor stopped him from having an expanding universe.
And this was like a mysterious repulsive force that went against gravity and actually stopped the universe from collapsing and kept it static.
He had to introduce a fudge factor into his mathematics, which turned out to be a mistake.
12 years later, Edwin Hubble discovered that due to the Big Bang, the universe is expanding. So Einstein had been right about the expanding universe, and wrong to add his cosmological constant, the so-called biggest blunder of his life.
The fact that all galaxies everywhere recede from everything else is a characteristic of an expanding universe, in fact. Just like if you bake a cake in the oven and it's got raisins in it, then every raisin will get further away from every other raisin as the cake expands. So it is that galaxies being like the raisins. So it is that space kind of puffs out. So in a sense, Big Bang is a bit of a misnomer. It should be called the big stretch or something like that. That's what Hubble had discovered with his observations of distant galaxies. And that actually was predicted by Einstein's theory.
And Einstein then realised that, in fact, he had the solution all along. He actually had the solution of an expanding universe, but he refused to go against the conventional wisdom at the time and accept that he was right and everybody else was wrong.
His equations, taken at face value, actually predict an expanding universe, so he kind of missed that trick.
The universe was actually expanding, so there was no need for this cosmological constant to keep it static.
And this was his biggest blunder. Even right up to his death, he realised that this should never have happened. He should have gone with his instincts and believed what he was actually doing and just stuck with it.
But as recently as 1998, scientists discovered that the universe isn't just expanding, it's speeding up too. Shocked by this result, they had to quickly invent a repulsive force to explain it away. And they called it dark energy, basically another name for the cosmological constant. So, even when Einstein got it wrong, he ended up being right.
In 1998, we discovered that the galaxies were actually moving away from each other faster. They were speeding up. So that means that the expansion of the universe was actually accelerating. So that means that there's some kind of repulsive force counteracting gravity and pushing the galaxies further and further away from each other. And this is actually quite like the cosmological constant that Einstein originally introduced, some kind of mysterious repulsive force. We call this dark energy at the moment, and nobody actually really knows what it is.
But in Einstein's equations, lo and behold, there is this effect that you can actually have a term that is acting against gravity. It's an anti-gravity term.
So the cosmological constant was a blunder in the sense that Einstein then missed the opportunity to predict the Big Bang, which would have been, another great feather to his cap. But it was not a blunder in the sense that we've now realised that there is something like a cosmological constant. It's not doing the role that Einstein originally thought, but it is there, so he was quite right to consider it seriously in his equations.
Who wanted Einstein for president? They say that politics is just show business for ugly people. Well, Einstein certainly never won any beauty contests. Maybe that's why he became so interested in the affairs of state. In Zurich, when he should have been studying physics, he was often found at the Odeon Café, a notorious hangout later frequented by the likes of Trotsky, Lenin, and Mussolini. After the outbreak of World War I, nearly 100 prominent scientists signed a paper supporting Germany's military aggression. Outraged, Einstein added his John Hancock to a pacifist counter-petition, bringing the final number of signatures to a total of 4. Before the next war, Einstein, who was Jewish, had a reward placed on his head by the Nazi Party, and his work became the target of their infamous book-burning campaign, which might explain why he decided not to stick around. But even after he settled in the land of the free, things weren't much better.
When he went to the United States, some of the scientists who had come out of Europe, they were beginning to think that the Germans were deliberately going after the building of the atom bomb.
Another scientist, Enrico Fermi, and 2 other Hungarian physicists who were living in America implored Einstein to write to President Roosevelt and urge him to develop a nuclear weapon before Nazi Germany did.
So this letter was written and it was addressed to Roosevelt, who was president at that time, and it encouraged Roosevelt to start an effort on the atomic bomb.
That must have been very difficult for him because he was, in his early years in particular, was a fierce pacifist and throughout his life campaigned for peace. So that must have been a really difficult decision.
The Manhattan Project, of course, was set up in Los Alamos. It was headed up by Oppenheimer. And Einstein, I believe, never actually visited Los Alamos. And when they dropped the bomb in Japan, or the 2 bombs in Japan, Einstein was absolutely horrified.
Wary of Einstein's socialist views and political influence, the FBI opened a file on him, collecting 1,800 pages of so-called derogatory information. They tapped his phone, opened his mail, and even went through his trash. While America also treated Einstein like the enemy, other countries were a little more welcoming. In 1952, the newly formed State of Israel asked him if he'd like to have a bash at being their president. He turned it down.
The reason he turned it down was because he was working in physics. That was the most important thing in his life. And I don't think that he felt that he had the political skills to manoeuvre a new country like that through the turmoil of the aftermath of the Second World War.
What happened to Einstein's brain? Sadly, Einstein departed these 4 dimensions in 1955. Against his wishes, and without the family's permission, autopsy pathologist Thomas Harvey removed the ex-genius's brain. Curiously, he also removed the eyeballs, which today reside in a New York safe deposit box.
He actually stole Einstein's brain. He was really interested in finding out if there was a physical connection between the brain and genius. He wanted to find out the essence of Einstein's genius.
Instead of handing over his cerebral trophy, Harvey sliced it into 240 pieces, pickled them in 2 jars of formaldehyde, and stashed them in his basement. He even kept the brain in a beer cooler, before eventually shoving it into the trunk of his Buick Skylark and heading west to California. He thought it would make a nice gift for Einstein's granddaughter, but strangely enough, she didn't want it.
And he took it all over the country trying to find eminent neurologists who would actually look at this brain and figure out why Einstein was such a genius that he was.
When they looked at the brain, they found that Einstein had a pretty average-sized brain. So that put paid to the idea that bigger brains meant that you were cleverer.
It's more interesting that there's such interest in his brain, because it kind of captures this idea that there's something biological about genius.
After 41 years, Harvey finally contacted a university researcher in Canada. She spotted that thanks to an underdeveloped Sylvian Fisher, Einstein's parietal lobe was about 15% wider than normal. This bit of the brain deals with mathematics and spatial awareness, definitely two of Einstein's better subjects.
Which makes complete sense because Einstein was able to imagine and really clearly visualise very abstract concepts that most people would have trouble with.
Later, a neuropathologist placed some of the sliced cerebrum under a microscope and discovered something rather remarkable. Einstein's 76-year-old grey matter showed almost no sign of ageing. So, the key to Einstein's genius may have been simply that he was young at heart, or brain at least.
I think the shape of the brain probably doesn't make much difference to how bright you are. I think the connections within the brain are perhaps more important than the shape or the structure of the brain.
When I think the reality, really, is that, you know, he was singularly hard-working. He had a philosophy in life which helped him to develop his ideas.
Albert Einstein was an amazing mind that gave us new insight into the universe around us.
Albert Einstein was a physicist who really rocked the boat in terms of classical physics at the beginning of the 20th century. He introduced new concepts and came up with new ideas that really had never been thought of before, and he changed our picture of the universe, and this has, universal implications.
Albert Einstein was the scientist of the 20th century. He laid the foundations of the 21st century science, and he also actually revolutionised our understanding of classical physics.
Albert Einstein was the greatest physicist that ever lived. And his ideas that he introduced are now at the heart of fundamental physics. They underpin it.
Not only that, he actually introduced us to the quantum world, which he actually didn't want to have anything to do with in later life. Having said that, he's probably the most famous person that came out of the 20th century.
He changed our view of our place in the universe, and not only, I mean, he kind of did it twice. He did it with his theories of relativity, and he did it in that he was the guy who really started quantum theory off with his idea of the light quantum. So, I mean, to do one of those things would have marked him out as one of the great physicists. To do both was something very special. Get quite emotional.